My name is Alex Galt. I'm a math teacher at Edina High School. This is lesson 1-1 in advanced algebra. It's a lesson about function notation. By the end of today, I want you to be able to understand and use function notation whether your function is presented as a table, graph, or equation. One way of thinking about functions is thinking about vending machines. With vending machines, we're used to typing in the number and getting our treat to come out of the vending machine. In this vending machine, if I type in a C4, my Ruffles comes out of the vending machine. If I want Skittles to come out of the vending machine, then I would have to type in a D8. So with function notation, the way we read this, f of D8 is equal to Skittles. If I want a Kit Kat to come out of the machine, I would have to type in a D1, so f of D1 equals Kit Kat. If I want Smart Food to come out of the machine, I actually have a couple of different options because Smart Food is in 2 slots of the vending machine. I don't think of the vending machine as broken if this is true. It just means that I have 2 different choices for getting Smart Food out. So I can have f of C0 or f of C2, and Smart Food still comes out of the machine. It's okay to have 2 different inputs give you the same output. If I type D3 into the machine, then the only thing that should come out of the machine is M&Ms. Looks like peanut M&Ms. If I type D9 into the machine, then I would be surprised if anything other than Reese's came out of the machine. And if I type C8 into the machine, then I should definitely get Ruffles. Okay. The machine works just fine if, in the case of like Ruffles or Smart Food, there's more than one input that gives us that output. But the machine is considered broken if I type an input and I get an unpredictable output. I definitely want to know what I'm getting out of the machine when I type the numbers in. The same is true for functions, but in math, we usually think of functions not as a vending machine, but in 3 different ways. We usually think of functions as an equation, a table, or a graph, and these are 3 different representations of a function. We'll talk about those throughout this lesson. So first we're going to think of a function as an equation. So we're going to think about the equation f of x equals x squared minus 3. The input is what we put into our function. So the input will be x. The output will be what we get when we put x in and we do a bunch of math. So the bunch of math is the machine part of the function. So if I'm using this function and I input a 4, then what I want to come out of the machine would be 4 squared minus 3, or thinking order of operations, so I'm going to do exponents first, 16 minus 3, or 13. So every time I input a 4 into this machine, I should get a 13 to come out of the machine. The machine has to work the same for everybody if I use the same input. So here are some examples of inputs. F of 2 would be 2 squared, which is 4, minus 3, or 1. I'd actually recommend that you pause the video and try to do these before I do them, because I'll go through them rather quickly. So you try them first, pause the video, and come back to it when you're done. So if my input is a 0, I square 0, I still get 0. 0 minus 3 would be negative 3. And if I input negative 2 squared minus 3, negative 2 squared is 4 minus 3, so my output would be 1. So f of negative 2 is equal to 1. F of 10 would be 100 minus 3, or 97. Okay. I want you to notice that we had 2 different inputs give us the same output. That's totally fine. It's okay for a function to give us the same output for different inputs. It's not okay for the function to give us different outputs for the same input. We can also think of a function as a graph. When we do think of a function as a graph, our inputs are the x-coordinates and the outputs are the y-coordinates. So remember that when we saw functions written out, they were written as f of x. So that means that 2 is an x-coordinate. So on a graph, if I want to know what f of 2 is, I look at where x is equal to 2, and I read what the y-coordinate is at that point. So that would be about, I don't know, 2.2-ish. Okay. I'm just estimating off of the graph what the y-coordinate is when the x-coordinate is 2. So pause the video for a second and try to use the graph to find f of -3, f of 0, and f of 3, and then try to figure out what inputs give us the following outputs. And I'll do it too. So if I input -3, my x-coordinate is -3, it looks like my y-coordinate at that point is 0. If my x-coordinate is 0, my y-coordinate at that point is 3. So f of 0 equals 3. F of 3 means my input is 3, my output would be 0. Totally okay that I got the same answer for 2 different inputs. If I want to know the input, if the output is 2.8, there are actually it looks like two different inputs give me 2.8. It looks like f of 1 would work, or f of -1 also equals 2.8. There's only one input that gives me an output of 3, because the y-coordinate is only 3 one time, so that would be f of 0. And then there are 2 different inputs that give me an output of 2.2. It looks like f of 2 gives us 1, and f of -2 also gives us 2.2. The machine is not broken if 2 different inputs give us the same output. The machine is broken if the same input gives us different outputs. So here's an example of a graph that is not a function. The graph of D is not a function because functions have to produce just one output when the input is the same. So if I look at this graph, f of 0 is definitely 0. It's the only answer that comes up, the only y-coordinate I get when my x-coordinate is 0. But f of 1, well, actually it's d, right, is the name of this function, but it's not even a function. D of 1 is confusing because at 1, my y-coordinate is 1, but it's also -1. So this is not a function because x equals 1 produces 2 different outputs. In order to be a function, every x-coordinate can only give you one output. So there's another test for functions. We're not going to spend a lot of time on it, but it's called the vertical line test. If I draw vertical lines through my graph, I should never hit the graph more than once if it's going to be a function. D is not a function because D fails that vertical line test. I hit it more than once as I draw a vertical line through the graph in many different places. Okay. The third way of thinking about functions is as a table. So in a table of values, the input is going to be the first column and the output would be the second column. One thing that I think when I look at a table is if I tell you the x-coordinate, you should be able to tell me the y-coordinate. It's okay for the y-coordinate, for different x-coordinates to give me the same y-coordinate, but it's not okay to be confused about if I tell you an x-coordinate, can you tell me the y-coordinate? So for example, if I tell you x is -1, you can tell me right away that y is 1. If I tell you x is 5, you can tell me y is 1. So this particular table is a function because each x-coordinate gives me a y-coordinate. This table is actually presented in a slightly different way, so I didn't want you to freak out if you saw your tables horizontally. But if I tell you an x-coordinate in this table, if I tell you x is equal to -1, you have a moment of confusion because you're not sure whether y should be 5 or 8. So this particular table is not a function because The same x-coordinate, x equals -1, gives you different y-coordinates. And then finally, in this table, each x-coordinate gives you a different y-coordinate. So this is a function. If I tell you x, you can tell me right away what y is. There's only one answer. Okay. So in summary, if I read f parentheses 4 equals 11, that means f of 4 is 11. The 4 is the input, or the x-coordinate, and the 11 is the output, or the y-coordinate for that function. In a graph, you can find the input by looking for the x-coordinates, and you can find the y-coordinate, the output, by looking for the y-coordinates. And since a function should only have one output for each input, graphs fail to be functions if they fail the vertical line test, or if you can draw a vertical line that crosses the graph more than once. And tables fail to be functions if the same y-coordinate gives you different x-coordinates. I'm sorry, I said that backwards. If the same x-coordinate gives you different y-coordinates. Okay, I hope that you have begun to understand function notation. Tomorrow we'll do more with function notation in the real world.